Hello, welcome to today's lesson. Do you know that both living and non-living things around you affect one another?
They do?
Yes, we say that they interact. Take for example your paperclip. What is it used for?
To hold sheets of paper together.
Good, they hold paper together. Your muscles and bones also interact together to enable you to move. Long ago, a Greek named Magnus discovered a black stone that could pull metals to it. This stone was named magnets after Magnus himself. Scientists now know that magnets are special stones that interact with some metals. Natural magnets are called lodestones. Some magnets are made of iron and steel. Sometimes they are painted to make them look attractive.
Some of them look so beautiful, they have become collectibles.
Yes, and magnets come in different shapes and sizes depending on their use. For example, bar magnets are used in compasses, horseshoe magnets in electric motors, ring magnets in computers, and button magnets to hold messages on magnetic boards. Look at these fridge magnets. Have you seen them before?
Yes, I have lots of them on my refrigerator.
Do you know what they are used for?
To hold messages and to make the fridge attractive.
Yes, they cling to the fridge. They interact with it. If you place the fridge magnets on a wall, it will fall off because the magnets do not interact with the wall. A magnet interacts with some metals. These metals are pulled towards the magnet when it is brought close to them. The magnets attract the metals. Metals that can be attracted to a magnet are magnetic. Iron and steel are magnetic. Nickel is also magnetic. Many forks, spoons, and knives are made of metal. Nickel can be found in some foreign coins. Not all metals are magnetic. Metals such as gold, aluminum, silver, and copper are non-magnetic. A magnet does not attract these metals. Can you identify the magnetic and non-magnetic objects?
I can.
Look at this bar magnet. Do you see the nails clinging to both ends of the bar?
Yes, why is that so?
Well, the ends of the magnets are called poles. The magnet's power is strongest at its two poles. Every magnet has two poles, whatever its shape is. A magnet always rests in the north-south direction. One end of the magnet points to the north. This is called the north-seeking pole, or the N pole. The other end points to the south. This is called the south-seeking pole, or the S pole. Do you know that magnets interact in an interesting way? Sometimes a magnet pulls the other magnet towards it, and sometimes it will push it away. This action depends on the poles of the magnet that are facing each other. When the end poles of two magnets face each other, they push each other apart. This will also happen when two S poles face each other. We say that like poles repel. When the N pole is brought to face the S pole, they attract each other. We say that unlike poles attract. Non-magnets do not behave in the same way as magnets. They do not attract and they do not repel. When you drop the magnet, it becomes weaker, so you must always handle a magnet carefully. Let's recall very quickly what you've learned.
A magnet attracts metals. Examples of metal are iron, steel, and nickel. A magnet does not attract non-magnetic objects. A magnet is strongest at its two poles. Every magnet has a north-seeking pole and a south-seeking pole. A magnet always comes to rest in a north-south direction. Like poles repel and unlike poles attract. Some magnets are stronger than others.